Pop quiz. Which of these formulas has 2 degrees of unsaturation? Is it A, C7H8, B, C5H10O, C, C4H6, or D, C6H6Cl2? Lock your answer in. We will reveal it soon with the reasoning. In this video, you will learn what degrees of unsaturation mean, how to calculate them quickly, and how to read that number to narrow down possible structures. Start with a big idea. A saturated hydrocarbon has the maximum hydrogens possible for its carbon count. Any ring or any pi bond lowers that maximum. Each ring or each pi bond removes the equivalent of 2 hydrogens from the saturated formula. Here is the working model. Degrees of unsaturation equals, open parenthesis, 2 times the number of carbons plus 2 plus the number of nitrogens minus hydrogens minus halogens, close parenthesis, all divided by 2. Halogens count like hydrogens. Nitrogen adds 1 to the total. Oxygen does not change the count. Let's try one example. For C5H8, 2 times 5 plus 2 minus 8, all over 2 equals 2. That means 2 degrees of unsaturation. It could be a ring plus 1 double bond, 2 double bonds, or a single triple bond. The count does not pick a single structure. Let's do a quick fix to a common mistake. Degrees of unsaturation do not tell you the exact arrangement. They only tell you the total number of rings and pi bonds. A triple bond counts as 2. Let's do a mini checkpoint. You have the rule and one example. Rings and pi bonds each count as 1, and a triple bond counts as 2. So far, so good. Want to check your progress? Tap the link for a quick practice test and a concise study guide tailored to this lesson. Quiz yourself, skim the highlights, and jump back in. Now include a halogen. For C5H9 bromides, treat bromine like a hydrogen in the count. 2 times 5 plus 2 minus 9 minus 1, all over 2, equals 1. So there is exactly 1 ring or 1 double bond in the structure. With nitrogen, add 1 in the numerator. For C6H7N, the count equals 4. 4 degrees of unsaturation often point to an aromatic ring, but the number alone is not proof. It is a strong hint to check for aromatic signals with other data. Oxygen does not affect the total. For C3H6O, 2 times 3 plus 2 minus 6, all over 2, equals 1. That 1 degree of unsaturation could be a carbonyl double bond or a ring. Again, the count narrows choices. It does not decide them. Here is a quick recipe. First, list counts for carbon, hydrogen, halogens, and nitrogens. Second, plug into the formula. Third, interpret the number as total rings plus pi bonds. Finally, generate a few candidates that match that number. And now, it's time to reveal the answer of the pop quiz earlier. Based on the choices, the correct answer is C, C4H6. 2 times 4 plus 2 minus 6, all over 2, equals 2. For the others, A has 4, B has 1, and D has 3. To recap, degrees of unsaturation tell the total number of rings and pi bonds. Use, open parenthesis, 2 times carbon plus 2 plus nitrogen minus hydrogen minus halogens, close parenthesis, over 2. Halogens count like hydrogen. Nitrogen adds 1, and oxygen does not change the count. Now that you've watched the video, let's see how much you remember. Head to the link in the description where you'll find Quizlet content made just for you.